So as a part of our lecture series in transmission and distribution, today we are going to discuss about HVAC transmission. So in the before lecture, we learnt about the transmission and types of transmission, in which it was divided into two, like AC and DC transmission. So this is extra high voltage AC transmission. So what are the three main stages in a power system? So it is generation, transmission and distribution. So when we come to the voltage levels, it is of many types, like low voltage, high voltage, very high voltage, extra high voltage and ultra high voltage levels. So in this lecture, we are going to see about the need for extra high voltage AC transmission, its advantages and disadvantages. So this picture clearly shows, this we might have seen when we travel for a long distance. So this is a clear picture which states the extra high voltage AC transmission system. And what is the need for extra high voltage transmission? So mainly economic considerations, technical considerations, increasing electricity demand and need for long distance transmission. So when we have to go for extra high voltage AC is when there is a need, or we have to travel the energy for a very long distance. So the adoption of HVAC transmission is driven by both economic and technical considerations, primarily related to the increasing electricity demand and the need to transmit power over long distances. So this is the main need for HVAC transmission. What are the economic benefits of HVAC transmission system? So when we transmit a power with extra high voltage, what are all the benefits that we can use of, which is reduced transmission losses. So we people talk, many discussions and many projects and research works are going on with the losses, whereas low power loss due to higher voltage. Since we transfer high voltage, so the power loss will be very low. Next one is increased transmission capacity, which is the ability to carry more power with fewer lines. Next one, lower cost per megawatt transmitted. So cost effective power delivery over long distances. So when we transfer a low voltage for a long distance, the losses also will be higher, so that the output efficiency may be decreased. So the cost may also gets increased. So when we go with HVAC, so it is of lower cost per megawatts transmitted, which is cost effective power delivery over long distance. And the right of way considerations, which is minimizing the load use impact in populated areas. Coming to the technical considerations, first one is long distance transmission, improved system stability, increased power transfer and enhanced grid reliability, and facilitating the interconnections. These are all the technical considerations which gives a better output that we can use for the transmission. So extra high voltage AC transmissions are very much beneficial. So coming to the components of substation, mainly we use circuit breakers. So circuit breakers are the main protective devices which is designed to interrupt the flow of electricity in the event of a fault or overload. So when there is a fault or overload, then this circuit breaker will interrupt and they act as a safety switch. So what are all the advantages when we transmit the power with extra high voltage? So it is high transmission capacity, which is it transmits large amount of power over long distances, and reduced transmission losses. So we call it as I square R loss compared to HV systems, and improved system stability, which enhances the grid stability and power transfer capability. So these are all the main advantages when we transfer power with extra high voltage. So whatever may be the advantages, we will still have a disadvantage of the system, where initial investment will be very high compared to low level voltage transformation. And environmental impact. So visual impact of tall towers and potential electromagnetic field concerns. So this is one of the concern. And when we go with our initial investment, so because we have to use a specialized equipments, and for creating the infrastructure, the initial investment will be high. So summarizing today's video of a extra high voltage AC transmission system. So the need for extra high voltage AC transmission is it is driven by economic and technical considerations, increasing demand for electricity and transmit power over long distance. Coming to the advantages, high transmission capacity, reduced transmission losses and improved system stability. And coming to the limitations, it is impractical beyond a certain level like 400 to 765 kilovolt. It is not practical. It cannot be used. So coming to the assessment, what is the main reason for using extra high voltage AC transmission? So the main purpose is to reduce the current and power losses. And bundled conductors are primarily used in extra high voltage where without using a single conductor, it is used as bundled conductor. So the purpose is in order to reduce the corona and radio interference. So I think today's video we have discussed about the extra high voltage AC transmission system, and here we have some references. We'll meet in the next video. Thank you.